Here we go. Properties of parallelograms. Now, I know you know what a parallelogram is. I know you know what quadrilaterals are. Now, what I want you to do is make sure that you have this information that I've got here in your little books. I'll give you a few minutes to go take care of it. Okay. Most of these should seem rather obvious to you. Played with parallelograms quite a bit over the years. Is there anything on here that seems rather interesting or that you look at it and go, huh? Besides the whole thing? Yes, I understand. So, the object of the game here is to try and be able to figure out how to deal with these things. Why are they the way they are? Quite often is the question someone needs to have. Okay? So, let's go and do this. I want to prove that opposite angles of a parallelogram are congruent. Okay. So, does this mean that z is the same as x? Does this mean that y and w are exactly the same? Is that what the opposites would be? Okay. So, we need to prove that these are congruent. Now, this is a parallelogram, right? So, W, X, Y, Z is parallelogram. And mind you, there's more than one way of dealing with this, okay? Given. So is ZW parallel to XY? Is this true? Okay. Definition of parallelogram. Okay. So, does this mean that the measure of angle Z plus the measure of angle Y equal 180 degrees? Is there a rule that we have seen at some point in time that says, hey, if I got two parallel lines, I got the angles that are on the same side, they add up to 180 degrees. Have we seen something like that? And the answer should be yes. Well, we have. This is the same side interior angles. Same side interior angles add up to 180 degrees of a substance. Now, does that also mean that the measure of angle W plus the measure of angle X equal 180 degrees? Okay. Now, one of the other things that we have here, could I also make this statement that ZY is parallel to WX? Can I add that up in there as a definition of parallelogram? Opposite sides are parallel. Does that then imply that I can take the measure of angle Z plus the measure of angle W is equal to 180 degrees? Because they're on the same side, correct? And that the measure of angle Y plus the measure of angle X is equal to 180 degrees? Okay. that all came from just this one statement. Okay? Knowing that opposite sides were parallel allowed me to go and make all four of those statements. Now you're going, yeah, so what? All of these are equal to 180, correct? I want to get that W and Y are the same thing, correct? So, could I go and say that, let's see, which ones we want the same? W and Y. W and Y. Okay. Can I then go and say that the measure, that the measure of angle W plus the measure of angle X, which is this one right here, is equal to the measure of angle Y plus the measure of angle X? That one. Can I do that? Okay, that's just a substitution, correct? Can I now say that the measure of angle W is equal to the measure of angle Y when I simplify? Do you see it? Do you see what I did besides just write something down on a piece of paper? I know that these two sides add up to 180. I know these two sides add up to 180. I know those two sides add up to 180. I know those two angles add up to 180. We know this. This is the rule. Because of that, I know that that's 180, that's 180. I chose those because I can cancel out the x's, yes? And then I am left with W and Y. If I want to go and take care of the X and the Z one, let's see, I need it where I get X and Z being the same thing. Let's see. Well, could I get by, if I use this one and this one, does that take care of it for me? Because that is Z and Y, this is Y and X, so that would give me Z and X, correct? Yes? No? Maybe so? So, now it turns out that I am going to put down that the measure of angle Z plus the measure of angle Y is equal to the measure of angle Y plus the measure of angle X. Substitution. And if I simplify, I end up with the measure of angle Z is equal to the measure of angle Y. Sometimes you've got to look at proofs as like a puzzle. What fits where? What do I need to go where? What rules do I have to work with? This is all it is. Is this the only way of doing it? Nope. I did this quite differently this morning in the first hour. Will the book do it differently? Yep. As long as you can justify your steps, you're okay. You might look at this and completely and go at it from a different way. Perfectly acceptable. As long as you can justify the rules with your steps. Correction, your steps with your rules. So, let's try another process here. I want to say that they are supplementary. What does supplementary mean? What does supplementary mean? Adds up to 180. Okay. So, what do I know about a quadrilateral? Got four sides, it's got four angles, okay? We're talking about angles here, so that kind of leads me to think, hey, is there something about the angles I should know? Is there something about the angles I can use? Because that's what I got to eventually get to, is to say something about angles. So I want to know what I know about angles in a quadrilateral. So has anybody got a thought about what is there about the angles in a quadrilateral? What do you know? Sometimes you just have to sit there and look at it. What's possible? Anybody got a thought? Two equal triangles. Okay. That could work. What else do I know about the angles in a quadrilateral? What? There's four of them. I know that. So I got four angles in a quadrilateral. What else do I know about angles in a quadrilateral? Is there? That would work in a parallelogram, but is that the case for all quadrilaterals? It's the case for a square, right? Would it be the case for a rectangle? Yes. Would it be the case for a trapezoid? There would have to be no. So, we know some things, we've had some thoughts. Hold on a sec, I talked about rectangles and squares. Those are real easy to work with, right? What do we know about the angles of rectangles and squares? They're congruent. How are they congruent? What are they as congruent? Right angles, which is 90 degrees. Because if I want to get congruence, remember congruence and equal and congruence, they kind of go hand in hand here, right? So if I know that they're 90 degrees, and I know that there are four of them, what must those angles do? Add up to what? 360, yeah. So I got to say that the measure of angle W plus the measure of angle X plus the measure of angle Z plus the measure of angle, what did we say? X, Y, Z, and W. W, X, oh, I forgot Y. Have to be equal to 360 degrees, correct? Now, how in blazes did I know that I had to go to a degree measure? Angles, yes, that's great. Supplementary. Huh? Angle addition. Oh, for this thing here? No. Sum of angles. Sum of angles in a quadrilateral. All quadrilaterals add up to 360 degrees. The reason why I went to degrees was supplementary. Supplementary means they add up to what? 180 degrees. Now, what do I know about angles in a parallelogram? You brought it up before that opposites were the same, correct? So could I say that the measure of angle Y is equal to the measure of angle W? Okay. And that would end up being opposite angles in parallelogram are equal. Okay. So since I know that those two are the same, could I use a substitution as follows? And also that the measure of angle Z is equal to the measure of angle X. Can I do that? So now for those of you that aren't paying attention, watch this. Can I go and say that the measure of angle W plus the measure of angle X plus the measure of angle X plus the measure of angle W is equal to 360 degrees by substitution? Can I do that? Yes. You said I get you guess. And you're kind of going, well, what in blazes would that do for me, right? Well, what does supplementary add up to? And 360 is two 180s, right? If I could kind of get this thing in half, this is going to help. And this is where the half comes in. I got MW over here, I got MW over here, so it's 2 times the measure of angle W plus 2 times the measure of angle X is equal to 360 degrees. Yes? That's just to simplify. And if I simplify again, does that mean that the measure of angle W plus the measure of angle X is equal to 180? Actually, that was the division property. Oh. Does that get me down there? Now here's the question. Can I repeat this process in here for all the pairs of angles? Most definitely. So I got my process now. All I would end up having to do is rewrite this so that I end up getting Z and Y down here, W and Z down here, X and Y down here. That's all I'd have to do is I've got this set up for it. I know that these are equal. It's just a substitution and simplify. Substitution and simplify. Does that make sense? Is this the only way to do it? There are other ways that you can sit there and figure this out. So, let's think about this one. Proving sides of a parallelogram congruent. Now this one's drop dead simple. And you're going, yeah, sure, it's drop dead simple. YZ now, of course, I've been doing this for ever and a day. So I can look at this and I can see what's going on with it. But I would like to know that the sides are exactly the same because that's what we're essentially doing here, right? I want to say that WZ is the same as this. I want to say that that is the same as that. One of the nice things that we could do is if I can get triangles congruent, their pieces are congruent. Yes, ma'am. No, those mean parallel. Remember when you got the little things that look like arrows, that implies that these two are parallel. That's what that's in. So, I want to go for this triangle here and this triangle over here. So, I am going to say that ZX is congruent to ZX. Is that legal? Huh? Reflexive. Okay? Reflexive property. And you're going, well, why in the world would I want to say that? Is ZX on two different triangles? If I cover this one up over here, the top triangle, let's just do it this way. Back here. If I go through and just erase this up over here and just say, hey, that's not there. I have ZX on a triangle, right? If I go and take that and move it down here and scribble out that one, do I have ZX on another triangle? Yeah. So I might as well have that line on two different triangles. That's why I need to say reflexive, because now I can go through and say that triangle WXC is congruent to triangle, let's see, YZX, Y, side, side, side. Okay? Now, I get to go and say the following. That, oops, sorry. That WZ is congruent to XY. I can say WX is congruent to ZY because of the corresponding parts of congruent triangles are congruent. CP, CT, C. That's what that was. Something you guys couldn't quite remember that when it came to dealing with one of the quizzes we used. So, that's it. Those three statements, four if you like, justify that those sides are congruent. As long as you can justify why you make the statement with one of the rules that we have, you're good. So, what about this? What do I know? If I am supposed to find the value of x, well, I see x in two places. What do I know about those two things that are with x? What do I know? It's a parallelogram, right? What do I know then about this and this? They're what? Okay, they're parallel. But I got to try and solve that for x. That means I got to run with numbers. That means I got to be able to say that 3x plus 10 compares to 7x minus 8 in some way. What way? Yeah, they're equal. Parallelogram. Opposite sides are the same. They must be equal. So that means I subtract 7x, I subtract 7x, I subtract 10, I subtract 10. I end up with negative 4x is equal to negative 18. Divide by negative 4, divide by negative 4, and x is equal to 9 over 2. So, I know this is 9 over 2. Did I figure out what the value of what x is? Have I answered the question? What question haven't I answered yet? I haven't gotten that far. Yes. Push, push, push. So, okay, so fine. You want me to solve the value, find the value of y. What do I know about this and this? They're equal, yeah, because they're on opposite sides. They're on the diagonal, right? Parallelogram, the diagonal bisects each other, so they have to be equal. So that means that 1/2 y plus 10 must be equal to 2y minus 2. Oh, I hate fractions. Remember that little trick from algebra? Well, that could be problematic. So, by the way, to get rid of a denominator in a fraction, just multiply through by least common multiple. Works really well. So, I am going to subtract 4y. Okie dokie. Minus 20, minus 20. And I end up then with negative 3y is equal to negative 24. Right? divide by negative 3, divide by negative 3, and I end up with a grand total of y is equal to 8. So that's got to be 8. So now did I get y? Now have I answered the question? Yes, no, maybe so. Again, you have to look at this. What is it that I know? You get algebraic expressions like this, more than likely they're going to be added together to get to something, or they're going to be equal. Those are the two things. So, let's try this one. It says, in Kansas, the highway department builds gravel roads to evenly divide parcels of land. If the farmer has a plot of land shaped like a parallelogram with a diagonal of 1 mile as shown, calculate the values of x and y to the nearest hundredth. Okay. So, what kind of triangles do I got here? What kind of triangles do I got? Right, I got right triangles. Good. So, let's say I'm going to take care of x first. I got a right triangle. X is referring to the sides. What could I use for figuring out sides of a right triangle? Oh, come on, the dude's second from the left up there. So, does that mean that it is going to be x squared plus 1 squared is equal to 2x squared? Is this true? So that means I get x squared plus 1 is equal to 4x squared. Remember, that's 2x. The whole thing's got to be squared. So I subtract x squared, subtract x squared, and I find out that 1 is equal to, whoops, 3x squared. Divide by 3, divide by 3. I get 1/3 is equal to x squared. So that means I got to take the square root of 1/3 is equal to x. Okay, so I've done the algebra. Calculator. Got the square root of 1/3 up there is 0.577. We're supposed to roll to the nearest hundredth, so that means that x is equal to 0.58. So if I put 0.58 up here, let's see, and if I double it, that would be 1.16, right? Does that seem reasonable for the distance for those sides of the triangle? If that's a mile, that's a little over a half mile. That should be, that makes sense. It's reasonable. What about the angles then? What do I know about those angles? Okay, they add up to 90 degrees. So that means that I have 3y minus 1 plus 9y plus 2 is equal to 90. So I get 12y plus 1 is equal to 90. Subtract 1, subtract 1. 12y is equal to 89. Divide by 12, divide by 12. Y is equal to, hey, you got to do to the nearest hundredths again. Grab a calculator. It looks like 7.42. So y is equal to 7.42. That's it. Again, look at it, what's your head up? What is it that you need to do? Are they equal? Do they add up to something? So, you know, you look at it and you think, well, that just sounds so easy when you say it. Think of it in those ways. So what I want you to do is I want you to give you a minute or so, and I want you to do this one. Ready? So, what are these things to each other? So I've got 4y minus 10 is equal to 2y plus 5. Subtract 2y, subtract 2y, add 10, 10. So we end up with 2y is equal to 15. Divide by 2, divide by 2. Y is equal to 7.5, 15 over 2. Does that seem reasonable? You've got the work down there, the justifications are there. So, give you a couple of minutes to play with this one. So, who can tell me what x is? Yes, sir, what do you have for x? X is equal to 7.5. Okay, I trust your answer is correct, but I shall verify. So, would that mean then that 5x minus 3 is equal to 4x plus 2? Yes? Yes? Okay, good. Add 3, subtract 4, x, subtract 4x, and I end up with x is equal to 5. Oh, you gave me z. Okay. You got 5? That made me feel better. So, who's got z? Yes, sir, what you got for z? 6? Z is equal to 6, so I can put down 2z plus 4 is equal to 3z minus 2. So subtract 4, subtract 4, subtract 3x, subtract 3x, negative, that's z's, minus z is equal to negative 6, so z is equal to 6, yes. All right. Give you a minute or a couple here to figure out these last. All righty. Since we heard from the gentleman last go around, ladies, one of you provide me with the value of x. Hannah, what you got for x? 2 2/3. Okay, so 13x plus 8, 7x minus 8. Okay, they're on the same side, so these two things must add up to 180 degrees. So I get 20x is equal to 180 plus 8 minus 8. Wipe out right there. Divide by 20, divide by 20. X is equal to 90. Did you set them equal? Okay. So again, it's one of those things that, okay, how do they relate to each other? How do they relate to each other? So, Leah, what you got for y? Okay. Well, okay. So how do y, or how do the ones with the y's relate to each other? Are they equal, or do they add up to something? Add up to something because they're on the same side. What'd you get? Yes. Yeah, it says 9 right there. Glad somebody's paying attention. So, oh, yeah, somebody's got to pay attention. So that would be 7y minus 22 plus 12y minus 7 is equal to, oops, 180. 180. So that means 15, no, not 15, 19. God, I can't even do math right. 19y minus 29 is equal to 180. Is that what we end up with? Add 29, I get 19y is equal to 209. Calculator time. And we get 209 divided by 19, and we end up with 11. There we go. Y is equal to 11.